Okay, this is going to be a review on radicals, which you did have in Math 2, but we're going to go over it again. And if you notice at the top of your page, you've got your common square roots. If you have these memorized, it's really going to help you do this a lot faster. So make sure that you can identify what your perfect squares are. So like 30, for example, 36 is a perfect square. Square root of 36 is 6. So it really helps to know, we've got 1 through 10 on here. It really helps to know, like 1 through 12, 1 through 10, if you can identify these numbers, like 1, 4, 9, 16, 25, and so on. If you can identify these as being perfect squares, this will really, really help you with simplifying radicals, okay? So for the first one here, if we take the square root of 8, well, 8 is not a perfect square. But what you want to do when you break down 8, you want to break it down, you want to think of two numbers that go into 8, and you want one of those to be a perfect square. So what you want to do is you want to look up here, and you want to see if any of these numbers, or actually any of your perfect squares, are factors of 8. Okay, so what you're doing is you're focusing on, okay, well, obviously 1 goes into 8, so we don't really use that, but does 4 go into 8? Does not? 9's obviously too big, but you're focusing on every time, do these numbers here go into that number in the radical? And that's how we break it down. So 4 goes into 8. So we're going to rewrite this as 4. Well, 4 times what gives you 8? 4 times 2. And then what you do is you split it up as the square root of 4 and the square root of 2. You give them each their own radical. And now the whole reason that we picked this one is because the square root of 4 is going to turn into 2. Now, your second one here, you'll never be able to simplify that one. That one is always going to stay a radical. So we just write that as the square root of 2. And that one stays your answer. Okay? So for B, the square root of 50. So you're looking at those numbers that I have highlighted up top. You're looking for the biggest one that goes into 50. So you're like, does 1, does 4, does 9, does 16, does 25, does so on. You're looking for the biggest one that goes into 50. So 25 goes into 50, and 25 times 2 gives us 50. So then we split that up, 25 and 2. And then now you take the square root of 25, which turns into 5, and then this one, like I said, will stay a radical, because since this number itself is not a perfect square, you will never be able to get rid of a perfect square completely, okay? All right, so 28. Okay, so for 28, the biggest perfect square that's going to go into it is going to be 4. So we write that as 4 times 7. And we do square root of 4 times square root of 7. The square root of 4 is 2. And then the 7 just stays in the radical. Okay? And at any time, if you want to pause the video and try some on your own, feel free to pause it and see how you do. Okay, so for 18, square root of 18. The biggest perfect square that goes into 18 is going to be 9. And, of course, 9 times 2. So we split that up, square root of 9 times square root of 2. The square root of 9 turns into 3, and that 2 just stays under the radical. Okay, so for 72, 72 is kind of a neat one, because you first initially think, well, 9 and 8 work, okay? But 9 is not the largest number that works. Okay, so we don't want to use that one. You always want to use the biggest one. 36 times 2 actually gives us 72. You always want to use the biggest. And the reason, if we go back up here, if I go back up to this one, the reason this doesn't work is because 8 itself has a perfect square in it. 8 has a 4 and a 2, where 4 is a perfect square. So you would have to continue to break that down. So that's why you always want to try to find the biggest one possible. Okay, so if we finish this one, the square root of 36, square root of 2, and then the square root of 36 is 6, and we leave 2 in the radical. All right, then we get to the square root of 75. So that will be 25 and 3. So square root of 25 times square root of 3, and then the square root of 25 is 5, and then we keep 3 in the radical. For 300, 100 times 3. So we have square root of 100, square root of 3, square root of 100 is 10, and 3 stays as a radical. And then for the square root of 20, we have 4 and 5. And I always like to put my perfect square first, just because that's going to be the radical, that gets rid of the radical first. And that square root of 4 is 2, and 5 stays a radical. Okay, so now we get into fractions. When you have a fraction, you can actually split it up and do it separately, square root of 3 and square root of 4, like that. Okay, so anytime you have a square root of a fraction, you can separate it. So when we do that, we get the square root of 3, and then the square root of 4 turns into 2. And then we are done with that one. Okay, so for B, if we split it up, we have the square root of 12 and the square root of 81. So first what happens, we do the square root of 81, that's going to turn into 9. Then when we do the 12, well, we have to break it down because we do have a perfect square that goes into 12. So that's going to be 4 and 3. So that'd be square root of 4 times square root of 3 over 9. Square root of 4 turns into 2. Square root of 3 stays a radical, and then we have our 9. Now, do not try to simplify the 9 and the 3. Okay, you cannot simplify it because 1 is a radical and 1 is not. The 3 is actually in the radical and the 9 is not in the radical. So you cannot simplify those. You just have to leave it alone. So this is as far as we can take it. That is our final answer. All right, for C, if we separate them into 2 separate radicals here, then we'll just get the square root of 5, and the square root of 9 turns into a 3, and that's our answer. Now, on D, if we think ahead a little bit, the square root of 3 on the bottom there, that's not going to do anything. It's not going to turn into anything. But what we can do, 60 divided by 3 is 20. And now we can reduce 20. We know that that's going to be 4 times 5 because we did it up above. Square root of 4 times square root of 5. Square root of 4 is 2. And we leave 5 in the radical. Okay, so now let's talk about variables. When we do variables, what you want to do is you want to see how many times your root will go into your power. So remember, if there's no root there, it's a square root. There's like an invisible 2 right there, okay? So you want to ask yourself, how many times does 2 go into 4, okay? And basically, you're just dividing. 4 divided by 2 is 2, so you're left with x squared, okay? Same thing here. Remember, there's an invisible 2 right there. How many times does 2 go into 2? Well, that's once, because 2 divided by 2 is 1, so you're just left with x to the first. Of course, we don't write x to the first. We just put x. So x is our answer. Now, what if we have an odd power, okay? Because 2 will go into 3 one time, okay? So 3 divided by 2 it's not a whole number. It's actually like 1.5. So this method is a little bit harder to use. So what we want to do here is we want to use like our long division rule. And a lot of you are going to get to where you can do this in your head, okay? 2 will go into 3 one time, and you have 1 left over, okay? However many times it goes into it completely, that is going to be your power on the outside, and whatever your remainder is going to be your power on the inside. So if you kind of think of it as doing long division, 3 into 2. Oops, I wrote that backwards. Let me start over with that, and let me actually use a different color, okay? So we're doing 2 into 3. 2 goes into 3 one time. 2 times 1 is 2. We subtract, we get 1, our remainder of 1. So we're doing old-fashioned division here, okay? So This is your power on the outside. This is your power on the inside. Okay, so if you see what I did there, this is your power on the outside. This is your power on the inside. Your remainder is like your power left over on the inside. So however many times it goes into it is your power on the outside. Whatever your remainder is the power on the inside. Okay, and like I said, a lot of you are going to be able to do this in your head. So remember, our invisible power here, our invisible root is just a 2. 2 will go into 7. If I would just talk through it, 3 times. 2 goes into 7 3 times. 2 times 3 is 6, which means you have 1 left over. Okay? Now, if you want me to write it out doing long division, we're doing 2 into 7. 2 goes into 7 3 times. 2 times 3 is 6, with a remainder of 1. So if you notice, oops, I meant to do my highlighter. Here's my 3. There's your 3. Your remainder of 1, your remainder of 1. Okay? Okay, on E, we have a little bit more to do because we have to reduce the 12 and we have to worry about the x to the 5th. So let's worry about the 12 first. So if I just worry about the 12, that's going to be 4 times 3. And then square root of 4 times square root of 3, which is going to be 2 square root of 3. And notice I left some space there to put my x's in. Now, remember our invisible root there is 2. 2 will go into 5 2 whole times. And we have 1 left over because 2 times 2 is 4. And then to get to 5, you have 1 left over. If you want me to work it out with long division, 2 into 5. So 2 goes into 5 2 times. 2 times 2 is 4. You subtract. You have your remainder of 1. So your power of 2 is here. Your power of 1 is here. And, normally we don't write these powers of 1s. We just, don't write them at all. But I'm just writing it now so you can kind of see where everything is going. Okay. So if we reduce 45, let's worry about the 45 first. Now I've got this negative on the outside. I've got 9 times 5. 9's my perfect square. And if I split that up, I've got negative square root of 9 and then square root of 5. So the square root of 9 is going to be 3. I'm going to leave some space, and I've got my 5. Okay? So remember, there's this 2 here. 2 goes into 6 3 times. And that's it. 2 goes evenly into 6, so I don't even have to worry about anything left over. Okay? Okay, on G, if I do my 40, okay, so I've already got my 3 on the outside. Okay, I have to think of a perfect square that goes into 40. So let's see here. 40, let's see what is a perfect square that goes into 40. I guess it'd be, the biggest one is 4. Okay, so 4 and 10. So got my 3. Square root of 4 is going to be 2. And then 10 stays in the radical. And I can go ahead and do 3 times 2. That's going to turn into 6. And I've got my square root of 10 in my radical. Okay, so remember there's that invisible 2. 2 will go into 9 4 whole times. 2 times 4 is 8. So I only have 1 left over. So that's my final answer. Now, if you want to see the long division, 2 goes into 9. So 2 goes into 9 4 times. 2 times 4 is 8. When I subtract, my remainder is 1. And so there's your 4 for this power on the outside. Your remainder of 1 for your power on the inside. I mean, technically, that's a power of 1 right there. Okay? All right, and then we get to 240. Oops. So I've got negative 5. All right, so if I think of some 2 numbers that go into 240, where one of them is a perfect square. Let's see, 240. Let's see here. What have we got? Okay. Let's see, 4, there's one bigger than 4. 9 doesn't go evenly. Okay, so 16 is my number. All right, so 16 and 15 work for that. So then square root of 16 gives me 4. And then negative 5 times 4, I can go ahead and say that that's going to be 20. I'm going to leave my space. There's 15. Okay, so remember, this is a 2. Okay, remember, this is a power of 1. 2 will not go into 1. 2 is too big, so I just put my x here, and that's just my answer. Okay? All right, so simplifying. All right, so what you want to do here is you want to multiply your radicals. If it's inside a radical, you can multiply them. If it's outside a radical, you can multiply them together. But you can never multiply something that's a radical and something that's not a radical. Okay, so for our first one, 2 times 6 we can multiply. We'll get 12. And then now we simplify 12. So 4 and 3. 4 is my perfect square. Square root of 4 is 2. And I leave 3 in the radical. Okay, for this one, 3 times 6 is going to be 18. So then I get 9 times 2. Square root of 9 is 3. And 2 is going to stay in the radical. Now, on C, what you want to do is you want to multiply the outside numbers and multiply your inside numbers. So 2 times 3 is 6. Oops. 6. And 12 times 10 is 120. And then now we can reduce 120. So if I want to think of my biggest radical that goes into 120, let's see here, 20 divided by, that'd be 4. So 4 and 30. The square root of 4 turns into 2. And then 6 times 2 is 12. And then I have my 30. Okay, so same thing on D. You can multiply the 7 and the 3. And that's going to give us 21. And then you can multiply the 5x and the 24x. And then that's going to give us, so 5 times 24 is 120. And x times x is x squared. Okay, so we know what 120 is going to reduce to. So that's the 4 and the 30 again. So we've got 21. Square root of 4 is 2. 2 will go into x squared, because remember there's an invisible 2 there. 2 will go into x squared one time. And then I just have my 30 in my radical. And then 21 times 2 is going to be 42. So I have 42x square root of 30. Okay. On E, we'll multiply our outside numbers. Negative 4 times 3 would be negative 12. And then if we multiply our inside numbers, we'll get the square root of 24x. Remember, add your exponents, x to the 5th. Okay, so when we break up 24, the biggest one is 4, so 4 and 6. Okay, so then square root of 4 is 2. Remember, 2 is my root here. 2 will go into 5 2 times, and we have 1 left over. So that takes care of my x's, because 2 times 2 is 4, 1 left over is 5. And then all I have to do is multiply these two, and I'll get negative 24 x squared square root of 6x. Okay, now here's a shortcut. whenever you have the exact same radical, square root of 2 times square root of 2, your final answer would just be 2. The reason that is because if you were to multiply that, you would get the square root of 4, and the square root of 4 is 2. Same thing here, square root of 3x, square root of 3x. Now, they have to be identical. They have to be exactly the same. Your final answer would be 3x. The reason is if we did multiply that out, you would get 9x squared in the radical. Well, the square root of 9 is 3, and then, of course, 2 goes into 2 one time, and you get 3x. So remember that shortcut, and it'll save you just a little bit of time.